Hello all. So as a continuation of my lecture series in transmission and distribution, now we are going to see something about mechanical design of overhead lines, which is a part of unit 3 sag insulators and line supports. So we learned many things about generation, transmission and distribution. So transmission happens through a transmission line. So in this unit, we are going to see about how to design a overhead line and what are all the parameters that we have to consider before installing a overhead line. So in this video, we are going to see about the design of transmission line, choice of transmission voltage, conductor size selection. So this conductor size selection plays a major role before installing a transmission line. So coming to design of transmission line, there are various technical and economic considerations involved in design of a transmission line. So the parameters which we are going to consider is power handling capacity of the line, distance of transmission, voltage regulation and efficiency are specified. So coming to the parameters, design of transmission line. So the basic thing is line voltage which we are going to transfer from one place to another. So the size of the phase conductors, the span which is the distance between the two poles, spacing and configuration of conductors, number of insulators, clearances and size of earth wires are included in the design. So before we design, we have to consider all these parameters before designing a transmission line. So with the help of the above mentioned parameters, the voltage regulation and efficiency of the transmission line can be determined. So the final motive is whatever we do, the final efficiency plays a major role before designing a transmission line or any motor or anything that we design. So the very important purpose is to meet the efficiency. A revised design is made if any of these quantities are not lying with the specified limits. So the choice of transmission voltage. So the line voltage, it greatly affects the performance of the line and its cost. So to achieve the optimum operating transmission voltage, so we have a formula 5.5 D by 1.6 into P by 100 power 0.5, where V is the operating voltage in kilovolts and D is distance of the transmission line. So we have to know what is the distance that we are going to transfer that particular voltage, and P is the power handling in kilowatts. A standard voltage nearer to obtained while above mentioned formula is selected for the given line. So to calculate the voltage, the above mentioned formula is used. So generally we classify the transmission line based on the voltage. So we have like medium transmission line, long transmission line based on the voltages. So if the voltage is between 300 to 765 kilovolt, then that line we call it as extra high voltage. And if it is greater than 765 kilovolts, we call it as ultra high voltage transmission lines. So before we design a transmission line, we have to check what is the voltage that we are going to transfer and what is the distance which we are going to travel. So these two are the very important parameters. So now coming to the conductor size selection. The size of the conductor, it should be properly selected during the design itself, as about 30 to 45% of total cost of line is involved in the cost of the conductor. So the conductor is the main role, so it takes the 30 to 45% of the total cost. So this is very important parameter. So the size of the conductor, it decides the cost of the towers and foundations. So how strong should be the foundation is based on the conductor size. The losses in the lines also depends on size of the conductor selected. So in the previous videos, we have discussed many things about the types of conductors, where here almost we use ACSR conductors, which is available in various sizes also. So we prefer ACSR conductors. So coming to the conductor size selection, so based on the temperature, so due to temperature, the sag associated. Sag is like when we have a transmission line between the two poles, then after some time we will have a U-shaped structure which we call it as sag. So why that sag occurs is it is based on the pressure applied on the transmission line. Like we don't cover any transmission line. For example, if we see any high voltage transmission lines, it is not covered. Yes, it is in the free space. So all the rains or moisture content all are deposited on the transmission line, which creates a weight. So the conductor itself has some weight. So which will as long as days goes on, so it will create a U-shaped structure. So during winter season, then we will be having a moisture content deposited on the transmission line. Due to its weight also, the conductor becomes U-shape, which we call it as sag. And due to high temperature, annealing of conductor takes place. Its typical value of copper and aluminum is around 100 degrees Celsius. So the operating temperature of the line must be below 75 degrees Celsius, and the losses we calculate it as I square or which happens due to the heating of the conductors. So based on the conductor heating and heat dissipation, temperature of conductor is increased. So the conductor size selection plays a major role before designing a transmission line. We will have a short assessment like which primary parameter is uniformly distributed along the length of the conductor is resistance, because the resistance is the primary parameter that is uniformly distributed along the length of the conductor. It depends on the cross section area and the length of the conductor. So the leakage current in the transmission lines is referred to as the conductance. The dielectrics or the insulators of the open wire line, it may not be perfect and the leakage current will flow. That leakage current exists between the conductors. So we will have a next video related to this. Thank you.